Hello, this is the section 6.4 and 6.5 lesson on the topic of division of fractions. Now we're going to do this a little bit differently than the book does. The book divides this up into two separate sections and looks at it from the how many groups perspective and then the how many items in a group perspective. We're not going to do that. We're just going to condense it down into one big section. We're going to talk about why would we divide fractions in the first place, and then how do we divide fractions, a little bit about why that works, and then lastly we'll talk about how do we set up a problem involving division of fractions, and then how do we know that it really is a division of fractions problem. So let's take a look at this first example. Now this example doesn't have anything to do with fractions, but we're going to use this to motivate our second example, which does involve fractions. So the problem says you have 6 cups of water. If a bucket holds 2 cups of water, how many of these buckets can you fill? So here's our picture. We're going to have our 6 cups up here. We're going to put 2 of those cups into the first bucket, 2 more of those cups into the second bucket. The question is, how many buckets are we going to fill? So this is a how many groups type of problem. So we're going to solve this by taking our 6 cups and dividing it by the 2 cups in each bucket. And we do that arithmetic, and so we get 3 buckets. So there's our answer. So that's how we set up a how many groups problem. Now let's look at this next example. It says you have 2/3 of a cup of water. If a bucket holds half a cup of water, how many of these buckets can you fill? Now notice that this problem is identical to the previous problem, except that we have different numbers. Instead of 6 cups and 2 cups, we have 2/3 of a cup and 1/2 of a cup. So our picture to set this problem up is going to look nearly identical to the previous problem. We're just going to have fractions instead of whole numbers. So we're going to put our 2/3 of a cup of water up top. We're going to put half of that cup into the first bucket, the half of a cup into the second bucket, ... So this is again a how many groups type of problem. So we can solve this in the same way as we did the previous problem. We're going to take the number at the top, 2/3, and divide it by the number of items in each group, which is 1/2, and we need to do that arithmetic. So that's the arithmetic that we need to do. Now the next question is, well, just how do we do that arithmetic? In other words, what number does 2/3 divided by 1/2 really equal? Well, let's look at this from a couple of different perspectives. The first is conceptually, and then we'll look at it more mathematically. And so let's start off with what we got here. It says we have 2/3 of a cup of water. So let's draw a picture of 2/3 of a cup. Okay. So here's a cup, and it says that we have 2/3 of a cup. So let's divide this up into thirds, and so there's our 2/3 of a cup that we have. Now it says next in the problem it says that each bucket holds a half of a cup. So in other words, to fill a bucket, we need a half of a cup. Well, let's draw a picture of a half of a cup. So we can do that, divide that in 2 pieces. And so again, this is a cup. This big box represents a cup, and this 1 piece is what we need. So it's like we have 2 pieces, but we only have 1 piece. Excuse me. Yes, we have 2 pieces, but we only need 1 piece to fill a bucket. Well, there's a problem here is that these pieces are all of different sizes, so let's make them all the same size. So we can do that very easily. Let's divide this in half and then divide this in thirds. And so what we see we have now is we have 1, 2, 3, 4 pieces. So we have 4 pieces. And then over here we need 1, 2, 3. We only need 3 pieces. And so we have 4 pieces, we need 3 pieces, so that means we have 4/3 of what we need. So if we have 4/3 of what we need to fill 1 bucket, that means we're going to be able to fill 4/3 of a bucket. 4/3 of a bucket means that we're going to be able to fill 1 whole bucket and then 1/3 of another bucket. So there's our answer. that 2/3 divided by 1/2 equals 4/3 of a bucket, or 1 1/3 of a bucket. So that's how we could draw a picture and use the meaning of fractions to reason through what the answer is. Well, let's look at this a little bit more mathematically, and this reasoning is going to lead to a rather simple algorithm for dividing fractions. So we want to divide 2/3 divided by 1/2. Well, first of all, let's convert this over to an equivalent multiplication problem. So this is equal to 2/3 equals question mark times 1/2. So that's an equivalent multiplication problem. This question mark here is the same as this question mark here. So now the question is, well, what number can we put here? Well, let's write it like this. 2/3 equals, and I'm going to replace this question mark with a big set of parentheses, times 1/2. And what I'm going to do is fill in these parentheses with the product of two fractions. Now just stick with me, you'll see where we're going here. So we're going to put a fraction right here, and I'm going to put a fraction right here such that when I take this fraction times 1/2, I get 1. So why do I do that? Well, just stick with me, you'll see where we're going. So what number times 1/2 would give me 1? Well, I could put a 2 over 1. Now, why is that going to work? Well, because if I do this multiplication, the 2's would cancel, the 1's would cancel, and I get just 1. So what we have right here is just 1, so I think of what number here times 1 is going to give me 2/3. Well, the answer is 2/3. And so what we've done is we showed that this number right here is the number that solves this multiplication problem. And so that tells us that 2/3 divided by 1/2, which is what that question mark originally represented, is the same as 2/3 times 2 over 1. Now what does that do for me? Well, this is multiplication of fractions. We already know how to multiply fractions. You multiply the numerators, you multiply the denominators. So we get 2 times 2 is 4, 3 times 1 is 3, and so there's my answer, 4/3. Exact same answer that we got conceptually, we just did this much more mathematically. Okay? But now look at what we did to do this division. Started with this division problem, we turned it into a multiplication problem. The first fraction is the same as the first fraction here, but compare this fraction to this fraction. Notice that all we did here was we flipped the numbers around. Instead of 1/2, it was 2 over 1. And so we can generalize this example in this algorithm. If we have a fraction a divided by, or a over b divided by c over d, we can take the first fraction a over b times the reciprocal of the second fraction, d over c. So that's all there is to dividing fractions. Take the reciprocal of the second fraction and you multiply. This first example helps to illustrate why that is true. Our previous examples dealt with how many group type of problems. Now let's look at some how many in each group type of problems. This first problem doesn't have anything to do with fractions, but it's going to help motivate our techniques for working with fractions. So this problem says you use 2 gallons of paint to paint 4 walls of the same size. How many gallons did it take to paint 1 wall? So we can draw a picture of this situation like here. We're going to put our 2 gallons at the top. Some of those gallons are going to go into the first wall, some are going to go into the second, some into the third, and then some are going to go into the fourth. So the question is, how many gallons are going to go into one whole wall? And so we've got our groups here at the bottom. We've got 4 groups. We don't know how much is going to go into each group, so this is indeed a how many in each group type of problem. And so we can solve this by taking the number at the top, 2, and dividing it by the number of groups at the bottom, which is 4. And so 2 divided by 4 is equal to 1/2. And so there's going to be 1/2 of a gallon go to each wall. Okay. Now let's look at the next problem, which is going to be very, very similar to the previous problem except with different numbers. This problem says you used half of a gallon of paint to paint 3/5 walls. How many gallons would it take to paint one whole wall? Well, again, this is pretty much the exact same problem as what we just did, just with fractions instead of whole numbers. And so we're going to set this problem up in the same way that we did the previous problem. In our picture here, we're going to put the total number of gallons that we used, 1/2. And then at the bottom, we're going to put the number of walls that we painted. So we painted one wall. Some of that 1/2 gallon went to the first wall. Some of the gallon went to the second wall. Some of the gallon went to the last wall, which we'll call wall number 5/3. May seem a little funny to call that wall number 5/3, but again, this picture is consistent with our previous picture. At the top, we put our total number of gallons. At the bottom, we put the total number of walls. And our problem asks how many gallons are going to go into one whole wall. And so this picture makes sense. From our picture, we see again that this is indeed a how many in each group problem. Each wall we can think of as a group, and we have a total of 5/3 groups. And the question is how many gallons go into one whole wall. So we can solve this problem just like the previous problem. We're going to take the number at the top, the 1/2, and divide it by the number of groups that we have at the bottom, which is 5/3. And so now we know how to do this arithmetic. We're going to take 1/2 times 3/5, and we do this arithmetic, and so this is 3/10, and so there's our answer. One whole wall is going to take 3/10 of a gallon of paint. Now our next problem is again very similar to the previous problem, just with slightly different numbers. You used 1/2 gallon of paint to paint 3/4 of a wall. How many gallons would it take to paint one whole wall? So again, almost identical problem, just slightly different numbers. Now in this one, we're only painting 3/4 of a wall, so it's not, we're not doing one wall, we're not doing more than one wall, but that's okay. We can still interpret this problem in the same basic way as the previous problems. In our picture here, we're going to put the number of gallons at the top, and some of that gallon is going to go to a first wall, and then to a second wall, and then the last wall we'll call wall number 3/4. Again, the picture may seem a little funny because 3/4 is less than 1, but again, this picture is consistent with our previous problems. And so then the question is, how many gallons are going to go to one whole wall? Again, we see this as a how many in each group type of problem. So we're going to solve this just like the previous problems. Take the number at the top, divide it by the total number of walls at the bottom, which is 3/4. We do this arithmetic. This is 1/2 times 4/3. We can simplify here a little bit, 1 and 2, and so the answer is 2/3 of a gallon. Okay. So this says that 2/3 of a gallon, that's our question mark, that's the number of gallons that's going to go into one whole wall. Now the benefit of drawing these types of pictures that we've talked about here are that sometimes in a word problem it's not obvious how to do the arithmetic or what number you're supposed to put on top, which number you're supposed to put on bottom. And so drawing pictures, we can do an educated guess and check until we find a strategy that works. And so let's look at this problem. 3/4 of a bag of jelly worms make 1/2 of a cup. How many cups of jelly worms are in one bag? So at the first glance, it's not at all obvious how to solve this. We're going to take an educated guess that it's a division problem, but then the next question is, well, what number do I put first? Do I take 3/4 divided by 1/2? Do I take 1/2 divided by 3/4? Just what do I do? Also, another question is, what type of problem is this? Is it a how many groups problem, or is it a how many items in a group type of problem? It's hard to tell just by looking at it. And so drawing pictures is going to help us to determine what type of problem it is and how to set it up. And so let's take an educated guess and check. First of all, let's guess that this is a how many groups type of problem. And so let's try to draw a picture for this. So maybe let's put our 3/4 of a bag at the top. And then we've got some unknown number of groups down here. I don't know how many groups, but maybe we need to put 1/2 of a cup into each group. And so, sorry, my arrows are getting a little crooked here, but that's okay. So this picture here, we use the numbers 3/4 and 1/2. This picture says that we're going to take 3/4 of a bag and put 1/2 of a cup into a group, and then 1/2 a cup into another group, and 1/2 a cup into a third group. But now we take a step back and say, well, now wait a minute, this picture doesn't quite make sense. I've got bags at the top, and I'm going to put 1/2 cup into some groups. So how do I put a cup from a bag, and then what's a group down here? I don't know, this picture doesn't quite make sense. So, a good first guess, but it didn't make sense. So maybe we think to ourselves, well, maybe I need to switch these numbers around. Well, let's try switching the numbers around. Let's put the 1/2 of a cup at the top, and then we'll put some groups here at the bottom. I don't know how many groups. And then maybe we're going to put 3/4 of a bag into each one of those groups. And then here's another arrow. So this problem says that we're going to start off with a 1/2 of a cup, and then we're going to put 3/4 of a bag into a group. But now, again, notice that these two units here don't agree. How do we start with cups and then put bags into groups? That doesn't make sense. And then what's a group? I don't know. So again, this picture doesn't really make any sense. And so what this tells us is that this is probably not a how many groups type of division problem. So let's take another stab at this. Let's think about it as a how many items in a group type of problem. And so let's try drawing a picture like this. Let's put our 3/4 of a bag at the top, and then let's put our groups at the bottom as, let's make our groups as a cup. So we've got like 1 cup, and then we've got a total of a 1/2 of a cup. So we're going to put our last group here, label as a 1/2 of a cup. And then we're going to put some bags into a cup. And so here is a how many items in a group type of picture. And so this picture says that we're going to put 3/4 of a bag into a total of 1/2 of a cup, which is what our problem says. But then this picture says how many bags are in one whole cup. Well, problem is that's not what the problem asks. The problem says how many cups are in one bag. So this picture is making a little more sense, but it's not exactly what we want. And so let's try this. Let's switch these numbers around. So let's put a 1/2 of a cup at the top, and then we're going to put our groups as the bottom, on the bottom as bags. And so we've got like 1 bag, and then a total of 3/4 of a bag. And then we'll draw an arrow here with a question mark beside it. Another arrow here. Okay, so let's look at what this picture says. This says that 1/2 of a cup of jelly worms go to a total of 3/4 of a bag. Well, that's what our problem says. Then our picture is asking how many cups are going to go into one whole bag. And that's exactly what we want. So this picture here makes sense. This picture tells us that this is a how many items in a group type of problem, and so we can solve this by taking our number at the top, 1/2, and dividing it by the total number of groups that we have at the bottom, 3/4. We do this arithmetic, 1/2 times 4/3, and simplify things a little bit, so this is going to be 2/3 of a cup. So there's my answer. This says that 2/3 of a cup are going to go into one whole bag. And that's exactly what we want. So again, this problem illustrates that when we look at a word problem, it may not be obvious how to solve it. And so sometimes it takes a little bit of educated guess and check to figure out how to solve it. Drawing pictures, taking a step back, looking at the pictures, asking ourselves, does that make sense? And go from there. That's one strategy we can use to figure out how to solve a problem such as this. So that's it for this section, for this lesson. The assignment for next class is to read sections 6.4 to 6.5 from the textbook.